there any questions at all about this? Okay, I'm just going to ask you quickly. Give me, just call out A, B, C, D, E, or F. Give me, call out a fraction, one of the improper fractions from number 1. Is there an improper fraction? B, right? That's improper. What about a mixed fraction?
D is also improper.
And D is,
And one more reminder, MLA Zoma is in the building and is in the student lounge to talk about their experience as being the first Black, non-binary, queer MLA in Manitoba. Come on down.
yeah, I think D would be regarded as improper. Give me an example of a mixed. Holler out. A is mixed. And how about proper?
I think I just transferred, so I need a booklet.
Okay, what's your name?
Nicholas, sorry.
Okay, have a seat. And C. Okay, so, and then also what you have to do was convert from mixed to improper, right? I think the exercise had you do it both ways, but the real skill that you're going to need, I guess the most important skill is to convert from mixed to improper. We're going to have to be doing that when we combine fractions. So if you found this one harder than this one, that's good, because this is the most important one. Let's convert H. So strategy is, I start with the numerator, 7 times, and I just go clockwise. 7 times 3 is 21 plus 2. This would be the improper fraction, 23/7. Agreed? This is a little harder because you have to kind of do, if you want to do it without a calculator, you got to do mental gymnastics in your head, like mental math gymnastics. So to convert the other way, I say it's just a division, right? It's 100 divided by 40. 40 goes into 100 twice with 20 left over, right? So my remainder is 20, and that sits on top of the 40. And I wouldn't leave it in this form. I would reduce. So it's called reducing or simplifying. If I explain it another way, it's the skill we did at the very beginning. The skill is just write the smallest equivalent fraction, right? First thing I would do is divide out the tens, right? So I have 2/4. So this is actually the fraction 2.5, right? I find this more work, it's longer, but lucky for us, this isn't really a skill that's as in demand as this one, okay? So that's where we left off. We good to go? And now we're going to do one of the more important lessons of one of these pre-skill classes, and it's combining fractions. And combining just means adding or subtracting, and adding or subtracting. So again, the rules that we learned in integers are the same thing in the world of fractions. So if we're combining numbers with the same sign, just add the numbers up together, keep the sign, like in integers. If the signs are different, then we subtract, right? Big minus small, just find the difference between the two numbers, and the sign follows the largest. Agreed? Remember that? Are you new? Okay. So let's do, now fractions take just a little more tweaking, so we're going to take it nice and slow. If you have lots of skill in this, that's great. Maybe help your partner out or your seatmate out if they're struggling a bit later on. But we're going to take it nice and slow. So the one thing to do to remember is, this is biggie. When combining fractions, the rules that we learned for sign numbers still apply. However, you knew there was a however coming up, huh? When we combine fractions, the bottom numbers, the denominators, must be the same, and they stay the same. If they are not the same, you must change all the fractions to equivalent fractions in order to combine them, okay? So once again, in big letters, to combine. And that means, the word combine means add or subtract, right? That's all that combine means. But it's a nice a nice word to use because I don't have to say add, subtract all the time, but to combine fractions, the denominators must be the same. And if they're not the same, we don't just skip the question and move on. We have to convert them to be the same, right? That's where the extra work comes in with fractions. All right, I'm just going to move this down to make it a bit bigger. If they are the same, adding fractions is a breeze, right? It's very easy. So let's take a look. I want you to add 2/9 plus 3/9. All right, the denominators are the same. So if they're the same, super easy. The denominator stays as a 9. And I just add, I ignore the denominator now. I've done the work of the denominator. 2 plus 3 is 5. So my answer is 5/9. Right? Doesn't get easier than that. What about the next one? Okay, it's probably going to be a little more challenging, but let's see. 2/9 subtract 3/9. Okay, well, denominators are the same, so I can proceed. So the denominator stays as a 9. But now you're just back doing the work that you did with combining, right? So if you ignore the denominators, I've got a positive 2. Think of this as a positive 2 and negative 3, right? Positive 2, negative 3. The signs are different. So the difference between 3 and 3 subtract 2 is 1. Is it going to be a positive or a negative?
Negative.
Negative. Why?
Because the negative is a larger number.
Yeah, the 3 is bigger.
So how come you don't do anything with that?
Sorry guys, hang on a sec. Sorry, I didn't realize the screen was so small. Sorry, Blanca?
I'm just wondering, why does the bottom number change?
Because we're just dealing with 9ths. Okay, how about, okay, let's go back to visuals. Okay, that's a good question. And I'm not a good explainer. Because basically I just said to you because. So what if I had, let's go back to this. What if I wanted to, like I had one circle, or let's go back to cakes, a cake. I had a cake. And this is what I had left of the cake. I had 1/4 of the cake and 1/4 of the cake, but I wanted to put them in the same cake pan. How many, the shaded part's what I have left. This is all empty, gone. How many, you know how you kind of do that with pizza sometimes? You combine the pizzas into one box? So how many pieces of pizza would I have left? 2? And if I put it in the same little box, then how many pieces would I have represented? 2/4. So 1/4 plus 1/4 equals 2/4.
But I'm just wondering if one's, you know how you're subtracting on the top, why do you do nothing on the bottom? That's all just like.
No, I
It's a
combine them
positive and
together
it's
into the
negative.
same box. I'm combining them. I'm combining 1/4 and 1/4. So,
No, I understand that part, but
Oh.
I'm talking about the positive and the negative, so you subtracted the 2 from the 3.
oh, I see.
But you didn't do anything.
No,
with
I
that.
did. I added the 2 and the 3. The 2s
No,
were
the bottom one.
yeah. So these were both the same sign, right?
Yeah.
So same sign. I add them up.
Yeah.
This was different. This was a positive 2 and a minus 3. So our rule is we subtract.
Oh, right, I guess the
So
bottom.
3 is 2 is 1, but it's going to be a negative 1.
Sorry.
Is that okay? Okay. So it's the same rules, right? No contradiction at all. Okay, let's go on. What do we have? Okay, so these are the same denominators too, so that's nice. I've got a negative 5/3 and negative 1/3, so I'm dealing in thirds. That's good. A negative 5 and a negative 1 is a negative 6. Agreed? Now, here's where it gets a little more work for fractions, because we always want it with fractions, when you're combining them, or when you're multiplying, dividing, they turn into new objects, and sometimes the new objects themselves can be simplified, like the final answer can, because I'm dealing with one number over the other. So would you simplify negative 6 over 3?
Yeah.
What would you call it? Yeah, it would just be known as negative 2. The more we can simplify in math, the better. Because that bar, the bar between the two, the numerator and denominator, is also the division bar. Okay, what about this one? A negative 2 and a positive 3 over 4. So the 4 is great, it stays. So I've got a negative 2, positive 3. Signs are different, so I subtract the numbers. When you subtract 3 minus 2, it's going to be positive 1. Okay? So these were all really straightforward, which was why we found them in example 1, because the denominators were the same. Agreed? Okay, let's go to the next set. You're probably thinking, okay, things might get a bit harder, and sure enough, they do. Combining fractions when the denominators are different. Okay, so I can't combine them when they're different. I have to. We must change one or both fractions so the denominators are the same. Okay, so what do I have here? I have 3/8 plus 1/4. Now, think of equivalent fractions.
2/8.
Yeah. So I look at the denominators, and Blanca's already jumped to a solution. So she says, I've got a 3/8 here, I've got a 1/4. I want to change them so they're equivalent. The smallest equivalent, I think, is to change them both to 8s, right? Would you agree? So with strategy, and I don't know if this you formally thought of this, Blanca, but I do the same as Blanca. I always look at the largest denominator, because the denominator at least has to be as big as 8. And I look, could my common denominator, so it's called a common denominator, would 8 work? Could I change 1/4 into equivalent fraction with 1/8? Yeah, quite easily, right? So we're going to change, I'm just going to show the work here. I've got 3/8 plus, I have my 1/4, and I'm just rewriting it so I can show my work. So what do I have to do to this 1/4, Blanca? What equivalent fraction? Times by 2's. So that becomes 3/8 plus 2/8. Okay, now I can proceed. Denominators are the same. 5/8 is my answer. So definitely a little more time consuming than just integers, because we're dealing with a number represented by two numbers, right? All right, so I have negative 2/7 minus 5/14. They're not the same, so I'm going to have to do some kind of conversion. I look at my biggest number, 14. Could I change 2/7 into a number equivalent fraction of 14ths?
Yes.
2 times
Yep.
7 is 14.
Again, just double it up, right? So I'm just going to double it up. So the equivalent fractions will be negative 4/14 minus, 5/14. Okay, I'm going to give you a sec to come up with the answer. What's the final answer? Negative 9/14. Okay, let's do, so far so good? Okay, now I have 1/2 plus 1/3. Got to change these, they're not the same. I look at my biggest number and it's 3. Can I do anything? Could 3 be the No, 'cause there's no way I convert, like if I double the 2, I get a 4. There's no way I can convert 2 into a denominator of 3. So I have to change both. Agreed? So for this example, we must change both denominators. And I'm going to show you a strategy that I use, but everyone comes from a different math place and a different math background. If you've got another strategy, use your way, but I'll show you a way that has worked for me in the past, and then you can tell me your method too. So I still look at the bottom number because the denominator at least has to be big enough for 3 to divide into, right? So 3 is actually my go-to guy at the beginning because 3 is the biggest denominator. So what I do is to find what we're trying to do is we're trying to find in math lingo, it's called the LCD. What does the LCD stand for? The lowest common denominator. The lowest common denominator. Now, common denominator just means what they, like, if I could just, it's just the 8, right, or the 14th. If the denominator is common, it's the same one. All of the ones in example 1 were common denominators. Lowest is kind of special because I want the lowest, I want the smallest fractions I can put them into because that saves me time at the end from simplifying. There's lots of common denominators I could find. There are infinite common denominators. But if I find the smallest one, it saves me work at the end. Okay? So that's why we're going for the lowest. So to get the lowest quickly, what I do is I start at my 3. So I pick my 3 and I just start counting by 3s. Counting by 3s gives me all the numbers 3 goes into. So 3 won't work. If I count by 3s, what's the next number? 6? Would 6 work as a denominator? Yeah. Why would it work? Yeah, 2 and 3 are both factors of 6. So 6 is my go-to. 6 is my LCD. So that's my LCD. So once I know that, it's really easy. So I'm just going to sort of transplant the question over here because I've taken a lot of room. So I have 1/2 plus 1/3. All right, so to get a 6 on the bottom, I have to multiply by 3s. To get a 6 on the bottom here, I have to double. So my first fraction becomes 3/6. Agreed? My second fraction becomes 2/6. Now I have my LCD, my lowest common denominator. It stays 6. 3 and 2 is 5. Comments, questions? Now, it's a coincidence, quite often I should say though, maybe it's more than a coincidence, quite often the LCD is found by just multiplying these two guys together, right? Did you notice that? That the LCD is, 2 times 3 was 6? But not all the time, right? So, okay, let's go on to the next one. 5/6 plus 1/4 plus 2/3. I'm combining 3 fractions. We can still do it. Now, unfortunately, they're not all the same fractions, so I start at my big number and I start counting by 6s. Okay, would 6 work? No. 3 goes into 6 evenly, but 4 doesn't, right? Okay, I'm counting by 6s. The next number would be a 12. 12 works, right? LCD is 12. Okay, I'm going to give you guys a sec. I'm going to get you to try this one on your own initially. anyone want to be brave and tell me your answer?
9 over 12.
Oh, you went to 12?
Yeah.
Oh, sorry, never mind. Yeah, of course. Of course you did. Who else agrees with 109 over 12? Sorry. Okay, let's see. Sorry, I had a brain lapse there for a sec. Okay, so multiplied by 2s? Yes. Multiply by 3s. Multiply by 4s. So what do we get here? Yeah, I think that's high. 10 twelfths plus 3 twelfths plus 8 twelfths.
Yep.
We-
21.
Yeah, I got the 21 too, I was going to say.
Yeah, that's what I got. Then I.
Did you multiply instead of...
No, I converted it to a mixed. I didn't know if to find like 9. I converted that improper fraction to a mixed number.
Okay, but even if we did that, so this is the answer. I figured it was 21. You don't have to convert, but if I wanted to convert to mixed, if I was going to bring yesterday's lesson, what would it be? It would be, how many times does 12 go into 21? Once, with how many left over?
9 over 12.
9 over 12, okay?
I got 3/4.
Yeah, and that could be reduced, right?
Oh yeah, I guess 1/3.
1 3/4. But honestly, this is not a useful form for really any type of math. This is where I would stop. So this is not necessary, unless I asked you to do a conversion, right?
Yeah.
But this is your final answer, because to be honest, if you're finding fractions, you're either finding a fractional answer or you're substituting into another formula quite often, and this is the form you would substitute in the form, okay? So are we okay with this? All right, ready to move on to the last set? There's nothing new here other than, what if you are given some of your work in mixed form? Okay? Why we did a little work yesterday on changing to mixed is, as I've said a few times already, mixed really isn't great for any type of math work. So the first thing we would do is convert everything to improper. Yeah. So anytime you have mixed, convert mixed to improper. And that will be the same when we're multiplying and dividing as well. We can't multiply and divide fractions in mixed form either. So, okay, so I have 2 2/5 minus 4/3. I see I have a mixed fraction. What else do you see? Do you notice about these?
Different,
Yeah, different denominators. So we're gonna have to do a bit of work here. So let's convert to, first let's convert, so I've got 2 times 5 plus 2, that'll be 12/5. Subtract 4/3. Okay, take a look at my largest denominator, 5. Could we go with 5 as a denominator? Would 5 work as a, no. Let's count by 5s. 5, 10, will 10 work? No. 15?
yes.
Yeah, 15's my LCD. Okay, excuse me. So I'm gonna have to multiply by 3s, multiply by 5s. That gives me equivalent fractions of 36/15 and 20/15. All right, I'm gonna take a minute, let you guys record the answer. Okay, final answer? Just 16/15. Positive 36 and negative 20? Yeah. And I would just leave it like that. Yes, that's improper, but just leave it. Okay, now we threw some quirky ones in just so we covered all the bases that you might see on an assignment or some kind of entrance exam if you ever write something like this. I did mention in class a few times, if you're going to a technical field, a lot of times they'll have an entrance or a diagnostic test, and they always include some fraction work like this. So then you can haul out your notes and look at this again. I've got 4/5 minus 6. Okay, that's a bit of a problem, right? The first thing we need is we need a denominator for each piece. So what's the, this is fine, 4/5. What's the denominator on the 6?
1.
Yeah, so write that in as a 1. Okay, what's my LCD going to be then? I went over that at the very beginning of class, Cliff. Any integer can be written as a fraction. So 6 is 6/1, isn't it? Isn't 6 divided by 1 6?
Oh, yeah.
Sometimes you need a denominator, right? That denominator is going to be 1. Okay, what's the LCD?
5.
It's got to be at least as big as 5. Would 5 work? Yeah, 5 goes into 5. Does 1 go into 5? Yep, so the LCD is 5. So that's nice. 4/5 minus 6/1. So I'd have to multiply by 5, multiply by 5. So I get 4/5 minus 30/5. Let's just take a minute here. 30 divided by 5, what is that? 6, right? I haven't changed anything. I've just written an equivalent form of 6 because I needed it in the question. All right, so my denominator is 5. Once you get your common denominator for combining, it's locked in, right? When you're combining fractions. I have a positive 4, a negative 30. Positive 4, negative 30, different signs. So 30 minus 4 is 26. And I have more negatives than positives, so it's going to be a negative 26/5. Okay. All right, nothing new to tell you for C, so I'm going to let you attempt that on your own. Okay, see a few pencils down. Who got an answer they want to share? What's your 19/5? Any seconders on that?
Yeah.
Yeah, I see some. Okay, let's see how you got your 19/5. So it's kind of nice that 1/5 and 3/5 are common denominators, right? So I got 1/5, and initially I had a 3/1. Okay, so 5 is the LCD again, right? For sure. All I have to do is multiply my middle term by 5s, and I'll get 1/5 and 15/5 and 3/5, which gives us 19/5. Perfect, and I would just leave it like that. Unless you're asked to convert to mix, just leave as improper. How are those old fraction cobwebs? They being dusted out of your head? Sharpening your skills again? Okay, one last question. It's not much different than C. What's the difference between D and C? Why do you think we included D? Yeah, it's a negative. Negatives always kind of throw one little wrinkle in. But other than the negative, it's the exact same process, right? Oh, and it has a mixed as well, okay? So let's do this. I'm going to try and do a few things at once. So 7 times 1 plus 3, that would be 10 sevenths, minus 4 over 1, plus 5 sevenths. So my LCD is 7. So all I have to do is multiply my middle term. And that gives me 28 sevenths in the middle, right? And some people can look at the 4 and jump right to 28 sevenths. That's great. If you want to avoid a few steps. All right, so now this time I have 2 positives and a negative. So going back to our very first lesson, some people were taking like out of their positives up first, subtotal, and then found the negative. So if I do that, I'll have a positive 15 and a negative 28, which gives me negative 13 over 7. Right? Or you could do it piece by piece, right? Either way, any way how you do it, how your eyes see it, we're all going to get the same answer, right? If we're doing it correctly, negative 13 over 7. Okay, this is quite a slow process, right? And it's very finicky because you have to make sure those denominators are the same, and if they're not, you have to convert them. And we actually got off lucky in a way because none of our, actually this final answer could have been reduced, right? We reduced it in mixed form. But when your final answers can be reduced, we reduce them. So actually, let's go back and let's reduce this one. What would the lowest equivalent form of D be in example 2? I have 21 over 12. How could I reduce that? Yeah, it's not, they're not even numbers, so if I divide a 3 out, it would be what? 7 over 4. So it would reduce to the equivalent fraction 7/4. No, I think I'll erase the mixed. I'll just erase them right out. And I'll just write it as 7/4. So equals 7/4. So all the skills that you were doing in finding equivalent fractions, that's really what you're doing when you're reducing to lowest terms, right? You're just finding the smallest equivalent fraction. Okay, I'm going to give you a bit of time to work on assignment 3. I don't think we're going to get to multiplying today, but we'll be able to do multiply and divide, I think, both tomorrow because they're very similar. Multiplying and dividing fractions are a piece of cake compared to combining. So that's nice. You've done the hard work with fractions. So you've got 20 questions. They start off easy, as you can see, all the same denominator. And then by number 9, they're going to start to change a little bit.